Before long, much of the planet would be coated in huge glaciers.
Wrong channel.
The grand freezings were triggered when overflowing volcanoes in Panama created the land bridge joining North to South America and radically altered global ocean currents. The polar seas cooled significantly. The result was that pronounced dips in global temperature could now tip the planet into ice ages lasting tens of thousands of years. Iceland. The Lonk-Jukul Glacier.
Too loud, son. Turn that
In the highest, coldest parts of the planet, glaciers still reign supreme. Few venture out in these hostile terrains, but glacier climatologist Finnur Paulsen and his team regularly battle the freezing elements.
When you're doing glacier fieldwork, conditions can be very bad.
Outside, it is below minus 20 degrees Fahrenheit.
I like to work in harsh conditions. Difficulty is something you need to tackle.
Finnur is keeping tabs on the growth of the glacier. At present, it is over 350 square miles, the size of New York City. And although it may look static, in fact, it is in constant motion. Glaciers are formed initially by snowfall on high areas. The compacted ice is then dragged down by the force of gravity. The glaciers move like slow-motion rivers.
You can think of ice as soft material like toothpaste. It flows. If you would make a big block of toothpaste on a plate, it would slowly sink down and flow away to the edges.
Finnur and his team in Iceland regularly check on the incremental movement of the ice.
This is a satellite positioning system. We can calculate the position of this point with an accuracy of about 2 centimeters. To calculate how fast the glacier moves.
Finnur's measurements tell him that this glacier is moving at over 150 feet per year. In today's mild temperatures, glacial advance is kept in check by glacial melting. But if global temperatures were to drop by just a few degrees for a long period, then the glaciers would grind slowly forward, and the Earth would enter another ice age. The existence of ice ages was first discovered by 19th century Swiss geologist Louis Agassiz. As he explored the Swiss Alps in the 1830s, Agassiz couldn't help but notice the immense boulders scattered over farmland, and the bizarre towers of gravel capped by stones that stood guard over some of the mountain valleys. To explain how the rocks arrived at these positions, he speculated that they had been carried and deposited by ancient glaciers that had once filled the alpine valleys and covered the northern hemisphere. Initially ridiculed by his peers, Agassiz's Ice Age theory became accepted as telltale signs that these huge glaciers had indeed covered the continents were found all over the globe. The evidence is everywhere. New York's Central Park. This oasis of green in the middle of Manhattan exposes part of the island's ancient bedrock. Many large outcrops are visible, and they contain the footprints of the glaciers. Climate expert Jörg Schaefer is looking for subtle traces of this frozen world.
It's actually something I bet that most New Yorkers do not know. You see the ice ages everywhere if you open your eyes.
Look closely, and the super hard bedrock is marked with scores of tiny parallel lines, fractions of an inch deep.
So this point here is actually one of the most amazing spots of evidence for an ice age in the middle of New York City.
The grooves were caused by small rocks caught under the massive weight of a moving glacier.
These little rocks basically cut like a knife into this very hard bedrock. This is clear proof that once an enormous ice sheet was moving in this direction in the middle of New York City.
The glaciers that hit New York were massive. They rolled down from the Arctic and buried Manhattan under a huge depth of ice.
To give you an idea about the thickness of the Laurentide ice sheet in the Manhattan area, it was at least twice as thick as the Empire State Building's height today.
Over the last 2 million years, as the climate fluctuated, the huge ice sheets waxed and waned. With every pass, they gouged and crushed and reshaped the land beneath. As the last glaciers retreated 10,000 years ago, they left behind a bruised and battered landscape and created features we still see today. In the USA, Cape Cod and Long Island are built on immense piles of boulders dropped from the retreating edge of the North American ice sheet. And the great weight of the ice formed huge depressions that now make up the Great Lakes. In the warmer climate that followed the last glacial retreat, early humans had free reign over the surface. In this brief period, a fraction of 1% of the history of the Earth, the entire history of human civilization has taken place. Human ingenuity has reshaped our planet. From our perspective, our achievements are breathtaking. But will we continue to survive and prosper?
Humans have, with technology, dominated the planet more completely than perhaps than any other animal in the history of life. But we've done it for such a short period of time that we've got a long ways to go.
Over the past 4.5 billion years, the Earth has been on the most incredible journey. Over the eons of its existence, the planetary environment has undergone immense transformations. And since the arrival of life, these transformations have in many ways determined which organisms will survive and which will be swept aside. If this turbulent past is any guide to the future, life, and humans in particular, will face further battles for survival as the planet continues along its path of change.
Life is highly dependent on the Earth. What the Earth gives us is what we have to deal with.
It's hard to separate completely the processes of geology and the processes of life. Life, in some ways, drives geology, and geology creates the environments in which life thrives.
Our first major challenge will be the climate. At the start of the 21st century, we may worry about global warming, but most scientists recognize that we are in a gap between ice ages. Our whole civilization has occurred in a brief warm period, 10,000 years so far. This warmth has proved crucial.
It's definitely not coincidence that civilizations developed over this period of time, because the climate is so favorable to our species to develop and flourish. The period we live in the moment climate-wise over the last, let's say, 10,000 years is exceptionally stable. It's almost unbelievably stable if you look into the geological record. It certainly will not stay forever like that.
Even if our industrial economies affect a global warming over the next couple of centuries, we can do no more than delay the inevitable. The continent's current positions, keeping the polar oceans cool, mean that in just 15,000 years, a new ice age may occur.
The New York area is going to be completely changed by the next cycle of glaciation. And at some point, glaciers are going to move down and grind New York into the North Atlantic Ocean.
But even if we survive the big freezes, there will be greater challenges to come. As plate tectonics move the continents and end the ice ages, coastal regions will be engulfed and whole countries will disappear. 200 million years from now, a new supercontinent, Pangaea Ultima, is due to take shape, as first the Mediterranean and then the Atlantic Ocean are swallowed up.
There will be continents eventually colliding with the east coast of North America. So New York, in the long run, will be destroyed in a continent-to-continent collision and will be completely crushed and thrust upward as a new mountain.
The Earth will once again be thrown into deadly turmoil. Oxygen levels and surface temperatures could fluctuate wildly and lead to new mass extinction. But even the trauma of supercontinental disruption is nothing compared to what will follow. Everything will grind to a halt when the plate tectonic engine finally stops.
The maintenance of habitability on this planet is involved with the plate tectonic cycle. It's not an infinite cycle. There is an end in sight. It's billions of years from now, but we know eventually the system will wear out.
The fires in the depths that have dominated activity on the surface will one day use up their fuel, and the story of planet Earth will be over. Without its burning heart, the Earth will share what many believe was the fate of Mars. The atmosphere and oceans will be stripped away, and the surface will become a bone-dry, barren desert. The planet will be dead. But this is a picture of an incredibly distant future. For at least the next billion years, as the Earth continues its epic journey, some form of life should continue. But the human species, which had walked the Earth for over 2 million years and mastered it only in the last 10,000, may be endangered. As the environment transforms, Earth could well become unfit for humans. If that happens in the distant future, rather than be forced to face extinction like our predecessors, technology may allow us to leave Earth in search of new homes, other blue-green planets on which to make a new start, leaving planet Earth to continue its amazing journey without us.